All right. So we're going to look at that picture and then we're going to draw some stuff, right?
Yeah. Specialized structures in the rocks. Define how deformation will result in a single answer. Compression, translation stress.
So the first question is, sketch the layers / structures in the rock. Do you want me to share my screen? I have it ready on Paint.
Great. Okay.
Fantastic.
Okay. So here it is. Woo.
All right. So we need to take a screenshot of that. And
yeah, so I can put this. I can put this on
that Google Doc.
Group Google Doc. Yeah, when we're done with it, so y'all can have it too.
Awesome.
Off the bat, you can see how it curves here, right? Curves right here.
Yeah.
Yeah, got a nice syncline.
Yeah.
Right next to.
Seems like there is a curve right there.
Right here?
Yeah. It looks like it.
There's some over here too. Do these formations look asymmetrical, or they look kind of tilted, right?
Yeah, they're definitely not perfectly up and down.
Mm-hmm.
It's definitely compression, right?
Mm-hmm.
How do we know when it's compression?
Oh, because compression, it's gonna make the waves, and like if it was tensional, it would just be like thinning and stretching.
Mm-hmm. Oh.
That's not how it's going.
That's still okay.
What else do we notice?
Well, it almost like the peak on the right, you can tell because it's a much lighter angle. At one point, that could have been a monocline because it just sort of and then steps down, but then it does have the syncline next to it.
Mm-hmm. Monocline.
Does this part of the rock here, does that look different from the top?
Yeah.
Finger. Much.
Yeah, I mean, if you look at it, you can see where it doesn't quite follow that same. Let's see. Let's go. It doesn't quite follow that same axial plane. As you can see where that line down further it
From here. Kind of down.
Yeah, further down, so you can just see that one line a little different. So just, yeah, like right there, that line, exactly.
Mm.
Because if I were to draw, because it sort of cuts through what I would call the axial plane of that syncline.
So when we say it's mononcline, what does that mean?
When we say syncline,
Monocline? Like
the
one,
monocline,
yeah.
the monocline is the one that's sort of like it's a step. So it goes, whoop. So it's almost, when we were talking about the right-hand side, it looked like it was a monocline, and then it goes right into a syncline right after that.
Mm. So monocline is like when it's normal, it goes down, like a step, like cliff kind of. Syncline to the left. Hmm.
Oops. So it said sketch the different layers. What do we notice about the layers? It looks to basically be the same kind of rock. Like I'm seeing distinct layers where it has folded, but I'm not seeing distinct layers of different types of rocks.
Mm-hmm.
Unless y'all see it.
It kind of follows a pattern because like they're like kind of like lines. They're not lines, but you kind of see like a line pattern too, and they're parallel to each other, kind of.
Mm-hmm.
Yeah, you can see the different layers. On the right-hand side, you can see where it's definitely like the bottom portion is a lot darker.
Mm-hmm.
Oh
So
yeah.
that one's a pretty. But I mean, in the main middle section, you can see lots of different layers. They're just not necessarily different colors.
Hmm. So would that different color be one that would be a different mineral, maybe, or maybe just has impurities?
And I cannot spell today. Apologies to all. Okay.
I'm back. I was. Hello.
Hello? Okay. So it looks like someone's already started writing the second question.
Maybe.
Mm-hmm. Nice. Okay. So it looks ductile because there are many scintile formations.
Ben, can you see? Can you help? Can you hear me?
Yeah, I can hear you, man.
With a thumbs up, maybe you can hear me. Can you hear me? Yeah.
I can hear you,
Oh,
buddy.
that's awesome. I cannot
Can you hear
hear
us?
you guys. Oh my gosh. Let me see. Let's
Well,
see.
if we can hear you, then that means that.
My computer's been acting funny recently. Okay, I'll try to connect. I'll join you guys again. I'll try to use the link and connect with you guys again. So to see if my audio comes back. Just 1 second.
I was just Emily, just trying to write out more, so you're not having to draw and write. So,
thanks.
so I was just, you keep drawing. I think we should probably put in some more markings just on those layers in the center section.
Good
Just
thinking.
to mark that we notice there are layers there. Yeah. Even just that, yeah, just a bunch of little sideways ones right there.
Kind of goes like that.
Syncline.
I see my artistic side failing.
Oh, you're good. Sometimes I'm not sure the whole dragging and curving it stuff. I always just draw, and it ends up looking messier. But
Is that good?
yeah,
Nice. Do you mind sharing what you're writing?
yeah. So I'm just so we definitely know it's ductile. So because it's
All
simply
right.
folding. Hey, Jashan.
Yeah, thank you guys. Yeah, I'm using my phone now instead of my laptop. It's restarting. Okay, but let's continue. Sorry, guys.
All right, so we're defining the deformation as ductile, and we can tell that because it has the syncline and anticline folds, and they're all nice, and there's not, I don't see any
Like,
noticeable big faults, which means it was
mhm.
under pressure and hot so that it could become more fluid
Yeah,
as it made its shape.
yeah. I
Because if
think
it
when
was
it's
brittle, we would see a lot more
kind of breaks, right?
fracturing.
Yeah.
Mm-hmm.
And I also feel like most of things in nature, it's gonna be. I mean, mostly it's gonna be ductile. There's always like a mixture. Like you see, like the tops, there's kind of like some fractures sometimes. But I agree with you guys. I think it's mostly ductile. Um, Even though we see some breaks, but most of it is ductile. I would say that too.
Hey, Jershawn, if you want to look at that picture and maybe zoom in, can we see any actual fractures where you can see that it's like slipped?
Let me see. You can see this. Um,
Because it seems pretty
I,
smooth to me. I mean, I don't see a whole lot of.
yeah. So like those parts in the top would be breaks. The very top, see like, but I don't know if that's considered to be a break. But I'm just saying the point I was saying is that usually in nature is like a combination of two things, white.
Yeah.
However, I think it's the ductile because most of it is the ductile, but there's always fractures a little bit here and there because it's not black and white, as many things in nature. But yeah, I was just looking at that top, and I don't know if that's a break or not. It just looks
Are,
as kind of not as curved.
like right here? Where it's all right
Yeah,
here?
like those parts, but kind of yeah. But I don't know. Would that be a break? Would that be brittle or just like it's not as
I don't think that would be a break. A break, if you think about, like, if you have really dry Play-Doh and it kind of
Mhm.
cracks or breaks off, that just looks like the top of the mountain, probably sharpened by weathering and storms and
Yeah.
that.
Okay. I see it. Thank you. Yeah, that's right. laptop would start. Yeah. Okay.
So what I have written for that question is, so we're saying ductile. There are syncline and anticline folds. There's evidence that it was under pressure and heat because it was able to bend without breaking, and there isn't much evidence of faults that would occur in a brittle deformation.
Yeah.
Okay.
So that's right.
And we can adjust it more later if we want to reword that. Sometimes that's my weak point, but
Yeah, I think it's great. It's great.
okay. So the next question is decide if it's compressional, tensional, or translational stress.
Mm.
So we definitely think it's compression, right?
Yeah.
I liked in our readings when they explained it like if you were to take a piece of paper on a table and then you squish it together, like it would make folds, and that's how you know it's compression.
Oh.
Um, I can't really think of what's translational stress. Is that like slip
Let's see.
or oblique faults type? I don't know.
In geology.
Mhm. So if this is a professional mountain, that means it's probably at a plate boundary, right? Probably at a continental plate and an oceanic plate switching together.
Translation. Let me see if I get this here in the textbook. Hmm. Um,
Boundary.
I have a little definition here for those tensional and compressional in the translation. It doesn't give us much information. It just says tensional stress stretches rocks, compressional squeeze them, while a shear stress causes slippage or translation. So I think it's when it is translation. I think it might be when rocks kind of like they have shear, like kind of like that, and that moves them, kind of translate them. That's what I think. Um,
Okay. So do you think there's any evidence of that stress in there?
I don't think so because there are no like breaks, like something move and break the other thing, kind of like a shear.
Mm-hmm. Sounds good.
Mm-hmm. No.
All right. So next is make observations of features of the fold that may or may not have been discussed in the text.
Mm-hmm. Okay.
Mhm. Well, we kind of already discussed a lot of the features. We have these here that are moving up and down, and the syncline and the anticline.
Yeah.
And possibly a monocline. I'm still not positive about it, but it does have a hint of that for sure.
Mm-hmm.
I almost. What do you guys think on that? Somewhat on the left-hand side, does it almost look like it is pushing up a little bit? Because you can see like there's the bigger peak, and then it goes to like there's another little peak, and it almost looks like I can't really tell on the layers on that, but yeah, that right there, I guess the layers just sort of continue down. So no. So
It does
but
kind
yeah.
of look.
So they're good. Sorry.
No, you go ahead.
Yeah.
So it does kind of look. It reminds me this right here, and kind of this right here. How in Colorado, where I'm at, the red rocks, they're tipping. So you see how like the oldest layers are on the bottom, the newest layers are on top, but it looks like it's tipping, almost flipping over. Right here.
Yeah.
Mhm. Yeah. I'm trying to do my best because from my phone I cannot do Zoom. But I'm
Yeah.
trying to follow along with you guys from my little tiny image here.
Well, wherever you need to zoom, just let me know and I can zoom in there. So you can see.
Okay. Thank you, Emily.
So I mean, we haven't really talked much about how the limbs, so between the syncline and the anticline, so they share that middle limb. Even though it's really pretty small, because the limbs on either side of both of those are much larger, but the limb between them is a lot smaller. But
Mhm.
That's true. Well, that's like here around this section. Oops. Oh,
Yeah.
looks like there's some rock sliding. Or like a rock deposit.
Mhm. Yeah. I don't know if this is right, but it kind of creates a like a path, and I guess depending on the environment and where these mountains are, when they get snow and when it melts, I think the water will naturally follow that path, and over time it kind of erodes it, you know. And
Yeah.
we can see that in those paths there are no vegetation because it's being eroded over time, because that's the water flow, the flow that follows naturally because of the lens. I don't think I just can just observe that right here.
Yeah, that's true. If it was ice, then it would carry stuff down with it as well as it melted. Because rocks and sediment and such would freeze in the ice and then be
Yeah.
carried down as it melts.
Mm-hmm. Exactly.
Good observation. Good observation.
very nice. Do we think at all that the left hand side that it might transition into a plunging fold because it sort of just dips off?
Like around.
Yeah. Or is that just? No, never mind. That would be going the other direction.
Um, you may be onto something though, because if you look at it, it kind of goes. Goes up, and then it has all these different waves. But even this rock is still going up, following the same pattern.
Yeah.
I think you're onto something.
Mm-hmm.
Well, I was just looking at my little drawing in my notes that it was like, because it's almost like, so if you imagine, so we got a anticline and it's going along and then it plunges in.
Yeah.
It goes along and then it plunges in. That's what I was thinking. So because we're looking at the layers and stuff like that, I don't see how it necessarily could be a plunge fold because we're looking at the layers and it's just probably the edge. It's just one of the layers just is longer on that side. I'm not sure if that makes
Do
sense.
we know,
Hmm.
just out of curiosity, do you know what mountains are these?
Um, I'm not sure what
Well,
mountains they are.
yeah, it didn't say anything about like where it is in the assignment. I was just curious because they're pretty, and I sometimes like kind of like understanding where they are and the environments around. You know, that can bring some insights. But yeah,
Does it say anything here? No. It just says it's like
yeah. The folds of anticline and cycline share the middle length.
Mm-hmm. I don't know of any other features of the folds.
yeah.
I mean, it is hard when there's vegetation in the way because we can't necessarily see all of what's going on. Because on that whole bottom side, we can't really tell how much of it is erosion, like Jashawn was talking about, from rain or snow, and because if all the trees and whatnot weren't there, then we might be able to tell more.
Yeah.
Let's look closely. What is this here? Do you see how the lines are going down? Is that like a
And it changes color as well.
Yeah, I mean that could be because it is a lot lighter. That could again just be another erosion place.
Mm-hmm.
Yeah.
I guess another thing you could mark, because if that one on the right hand side is a monocline, it does have right where it bends. That technically would be another axial plane.
Mark where?
Right where your cursor's at. So it would be going straight up because right there where it makes that bend.
Oh, I see it now.
It would be sort of going at a slant though. So following that line, like you got that your cursor was just on. Yeah, exactly. Yep.
Okay, I see it.
There we go. That's pretty much all.
Yeah. Look through. What is this dark little section here? Could that be evidence of what Jashawn was saying about water and snow melts off the mountain?
I mean, it could be. It's hard to tell with whether there's like actual depth, like going up, or if it's pretty sheer, it wouldn't be. But
Yeah.
Is there snow? Is that why stuff? Is it like rocks, minerals, or is it snow? I cannot. Or it's both.
I think it's rocks.
It's rocks. Just rocks, right?
Wonder what type of rock.
Yeah.
Think about that for a second. And see it. It's
Maybe some granite or quartz in there.
that it asks? No. Okay.
Here we go.
All right. Let's see.
Mhm. Mhm. Is there any other feature that I want to highlight? I think we've talked about almost everything. The falls, all the features that it's asking us here as well.
Mm-hmm.
Yeah, I think we covered most of it. Is there? I mean, if you guys want to even just talk about anything else we found interesting from this week's stuff.
Like it's been cool because I was reading some of the art bibliography. Like at first, most of the articles were super hard to understand, and then yesterday I noticed I was reading one about rocks, and we've been talking a lot about rocks, metamorphic, sedimentary rocks, and now at least the names were not unfamiliar to me. I could feel like, hey, I've heard of this. I kind of know what they look like. So it was kind of nice to see that as we go into this activity, it gets less, I don't know, we get more familiar with the content. It's nice to see that. It's nice.
Yeah, it is really nice.
But it's still pretty, there's some articles that I feel like I'm reading Japanese because they're really hard, but getting better little by little.
Yeah, I felt like this just week in general, like chapter 10, there was just a ton of different terms, and it was surprising that they had so much all about the deformation and they have all the different faults, and then there was like the only part that they didn't really hit in any of the questions or like that was when it was talking about the fault blocks. So there was the Horst Graben, half Graben, and then Clippy, which is like a cliff. So I thought they would have hit those a little bit more. It would have been nice to have more visual aids with some of those too, but they didn't really show a lot with those.
Oh yeah, most definitely. I think with this class, the more visual aids we have, the better.
Yeah, watching those videos in the Pearson is what really puts what you're reading actually
Yeah.
in place. Like you're able to actually make sense of it once you can see it.
Yeah. Because
I can't
I mean, like
wait
here
until
on campus, and also just question like because here on campus they have a lab, so we have samples of all kind of minerals and rocks, metamorphic, sedimentary. Um, but I think it's even harder because you guys are taking this the lab. Are you guys taking like a lab along with the lecture class?
No, sir.
There's yeah.
No, I
I
don't
think
think it's
it's even
possible for
harder.
online students to take the lab.
Yeah, that's true. But I think it's in you guys are doing great. For me, that I'm here on campus. We have the lab. It gets hard sometimes, but I think you guys are doing great. I learned a lot when I listen to you guys, so that's a good sign.
This class, I think I put more time into this class than any of my other classes. Just because it's a lot of information, and there's cool stuff though. Because I think I remember reading about how So not fractures, but the joints, where it's just that it's a break, but it hasn't moved. And how they were talking about how that's where like gold and stuff will find its way, and that makes me want to go find some joints, find some gold.
Yeah.
I can't wait till later chapters start talking about how planets and stars and stuff are formed. That's going to be really interesting.
That is true. Yeah. This week we have the test as well.
Yeah.
Have you guys taken it yet?
No.
Yeah. I still.
Studying too. That's what was it on. But anyway, so if there's nothing else we want to discuss about the assignment, then I'll go ahead and stop the broadcast.